Hello everyone. Today we will look at some of the relations of greatest integer function. On the whiteboard you can see two columns. The first column tells us the information that is given to us, and the second column we have to figure out what is the relation between the two terms. Basically we have to replace the question mark with proper relation. If we are given a, what can we say about a and its greatest integer function? What's the relation between them? This follows from the definition of greatest integer function that the greatest integer function of a is the greatest integer that is less than or equal to a. So what you are looking for is this sign. Another technique to solve greatest integer function kind of questions is a number line representation. So what the definition says and what we are saying here is, like, let's assume there is a number line, and on this number line we mark some integers 0, 1 all the way up to, let's say, greatest integer of a. And the next one would be greatest integer of a plus 1. These are integer numbers. A would fall somewhere here. It will be either greater than the greatest integer function or equal to it. So a could be right here, or it could be anywhere in between. So the right relationship is a is greater than equal to greatest integer function of a. Next one. This next one is a very simple property. We are given that number a is equal to number b. The question is, what can we say about the greatest integer of a and greatest integer of b? I will start with giving the answer to the question, and then we'll go through the explanation. So if a is equal to b, we can confidently say that the greatest integer of a would also be equal to the greatest integer of b. Again, let's do this with a number line. So we are given a number line. On this number line, let's mark some integers. So let's start with 0, 1, 2. At certain point there would be a greatest integer of a, because that is the integer, and the next one would be greatest integer of a plus 1. That would be the next integer. Let's say a falls somewhere here, right? And that's why we get the greatest integer, just the integer which is greatest but less than a. We are given that b also falls exactly at a, because a equal to b, which means the greatest integer of b would also fall right here. Hence, if we are given that a is equal to b, then the greatest integer of a would also be equal to greatest integer of b. So in the third property, we are given that the greatest integer of a equals the greatest integer of b. What can we say about a and b? This is kind of the reverse of what we did in 2, and this is a little bit more interesting and tricky. So let's see, we are given that the greatest integer of a equals the greatest integer of b. We'll solve this in two ways. One with the number line, because I think it helps understand better, and then also with a few examples. So let's draw the number line. What we are given is, on the number line, let's mark some integers 0, 1 all the way to greatest integer of a, and the next one would be, of course, greatest integer of a plus 1. We are given that greatest integer of b is equal to greatest integer of a, so b also lies somewhere here, not somewhere here, exactly here. What that means is a and b lie somewhere in this range. Now we don't know where. right? So let's say A is here. What can we say about B? B could be somewhere here, exactly here, somewhere here, somewhere here. From this number line representation, what I think this means is I cannot establish a relationship between A or B. So what I would say is I cannot replace this question mark. It stays here. I cannot say what is the relation between A and B. Let's take some examples and see if we are able to demonstrate the same thing with examples. Let's say greatest integer of A equals greatest integer of B equals 2. So if that is the case, let's start taking some values. Let's just take A equals 2.5, right in the middle of 2 and 3. What I will get is greatest integer of A will stay at 2, right? Which means greatest integer of B is 2. We have already established that. Now let me take some values of B. If I take B equal to 2.5, which means A equal to B, I will get greatest integer of B equal to 2. If I take B equal to 2.6, I will still get greatest integer of B equal to 2, and in this case B is greater than A. If I take B equal to 2.4, I will again get greatest integer of B equal to 2, but in this case B is less than A. So as you can see, we cannot establish a real relationship between A and B. It could be anything. In the fourth property, we are given that A is greater than B, and the question is, what can we say about greatest integer of A and greatest integer of B? Can we say that greatest integer of A will also be greater than B? Let's find out. So let's take some examples to solve this thing. Let's just say A equals 2.5 and B equals 2.3. As is given, A is greater than B. As you can see, greatest integer of A here would be 2, that is the greatest integer less than A, and greatest integer of B will also be 2. So there is equality possible here. Let's take another example. Let's take A equal to 3.5 and B equals 2.3. A is greater than B. In this case, greatest integer of A is equal to 3 and greatest integer of B equals 2. Here, greatest integer of A is actually greater than greatest integer of B. So what that gives us is the relationship between greatest integer of A and greatest integer of B is not same as the relationship between A and B. It is actually this relation. It could be greater or it could also be equal to. In the property number 5, here we are given the reverse of property number 4. We are given that the greatest integer of A is greater than the greatest integer of B. And then what can we say about A and B? So this is best understood on a number line. So let me draw a number line. Not the straightest of number line, but we will make do. Since greatest integer of B is less than greatest integer of A, I'm going to assume greatest integer of B lies somewhere here, and then greatest integer of A lies somewhere here. Now A could be just the next consecutive, greatest integer of A could be the next consecutive integer after greatest integer of B, but for the sake of argument, let's assume this represents greatest integer of b plus 1, and then there is some gap there, and we can make that gap 0 later on, but for now, and then we have greatest integer of a plus 1 as our next integer. So what I have just represented here is this relationship. Greatest integer of a is greater than greatest integer of b. This is clearly represented in the number line. You can collapse these two and make them a single point. It still means that b will be here and a will be here. B will be, greatest integer of b will be on the left of greatest integer of a. From the definition of greatest integer, what this means is that b will lie somewhere here, and it will never be equal to greatest integer of b plus 1, and a will lie somewhere here. Even if you collapse these two, the range of b, the possible values of b, would always be on the left of possible values of a, which means b will always be less than a. Even the greatest possible value of b would be a little smaller than the smallest possible value of a. So the right relationship here, you can safely say, is a is greater than b. So friends, here is the final chart of the relations. I hope you found the video helpful, and I hope this helps you solve the greatest integer problems a little better. In the next video, we will try to dig a little deeper into the operations of greatest integer function and what we can and cannot do with these operations and operators. Have a great day.